Hi guys, this is Mrs. Foy, and this is a screencast on the endocrine system to talk about how blood glucose is regulated. So this is blood sugar, your blood sugar. And there's actually two hormones that have to do with how your blood sugar is regulated: insulin and glucagon. Both of these are hormones, and they are actually produced in the pancreas. And this is where the pancreas sits, kind of behind the stomach. And we'll talk about more about the pancreas in just a minute. So the first thing we need to get straight is the difference between glucose and glycogen. Glucose is a monosaccharide. So this is C6H12O6, right? Glucose. This is the fuel that we use for making ATPs and cellular respiration. And glycogen is a polysaccharide. So this is going to be a chain of glucose molecules, that is an animal starch. So you can see there's glucose, 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 all bonded together to form this big molecule called glycogen. Unfortunately, glycogen sounds a lot like the hormone glucagon. So you got to keep all your G's separated, okay? So glucose, glycogen. Glucose is a sugar. Glycogen is a starch, a polysaccharide. So there are two hormones that keep blood glucose in homeostasis. One is insulin and one is glucagon. I'm really sorry, but that sounds kind of like glycogen. Don't forget that glucose is the sugar and glycogen is the starch. Okay, so don't get these confused with hormones, which are chemical messengers in the blood, insulin and glucagon. And as you can see, these two hormones work antagonistic to each other. So just like in your literature, antagonists work against each other, so does insulin and glucagon. So insulin is going to decrease the blood glucose level, and glucagon acts to increase the blood glucose level. So these two hormones are going to work in homeostasis to keep that blood glucose level balanced. So we're going to look at insulin first, and what we see is that glucose, the molecule, is really too big to just diffuse into a cell. And remember, this is where that glucose is going to be burned. Glucose is going to be burned as a fuel. And this is actually not a cell wall, this is a cell membrane. So just make sure we got that straight. So we use glucose as a fuel, but glucose cannot just get into the cell. It actually needs insulin as the key. And insulin is the hormone that is going to allow glucose to get into the cell. Without insulin, glucose would just build up in the blood, and you would have higher and higher levels of glucose in your blood. So we can see what happens is that when glucose is in the bloodstream, insulin is also released into the bloodstream, and insulin is going to bind to the cell. So here's a cell, and it's going to act like a key to allow glucose to get in, and then it's going to be used to burn energy. Or excuse me, it's going to be used as a fuel to be able to make some ATPs. So here's the basics of how these two hormones work. So first of all, let's talk about insulin. Insulin is released by, oh, this is wrong, guys. Sorry. These are beta cells. Insulin is released by beta cells in the pancreas, and they act on body cells to be able to absorb glucose, thus decreasing the blood glucose level. And glucagon, is released by alpha cells in the pancreas, and they mostly, glucagon, this hormone, acts on the liver, And what it does is it stimulates the liver to take glycogen, which is the starch, and break it down into glucose, which increases the blood glucose level. So let's take a further look then at the pancreas. So let's take a look at what happens when we have a high blood sugar level. So this would be the stimulus. We have a high blood sugar level. And what that does is that is going to stimulate the pancreas, which releases the hormone insulin into the bloodstream. And what that does is that is going to act on two different major body parts. It's going to act on the muscles in our body, and it is going to say, okay, we've got plenty of sugar, so you can start to store some of that sugar as glycogen. It also tells the liver the same thing, and it also is going to tell regular body cells that they can, this is body cells, that they can absorb glucose and use it to make some ATPs. And so as that happens, we can see that the outcome of that is that the blood sugar would be reduced. In the opposite situation, if we have low blood sugar, that stimulates the pancreas to release the other glucose hormone called glucagon. Glucagon majorly acts on the liver, and it tells the liver to take some glycogen, which is our starch, and to break that down into glucose. And the glucose is then released in the bloodstream. There is actually another hormone that's produced by the adrenal gland, which sits on top of our kidney, and that releases another hormone called adrenaline, which is our fight or flight. And that basically does, that gives the same signal to the liver to release a flood of sugar. And so this is going to increase our blood sugar, and so it acts in an opposite way. So here is a look at the pancreas itself. So you can see here's the pancreas, and the pancreas actually acts as an exocrine gland. It acts as an exocrine gland, and it also acts as an endocrine gland. We'll learn more about this in class. So as an exocrine gland, it is releasing digestive enzymes, and also it's going to release some more neutralizing solution to neutralize what's coming out from the acid. And so these digestive enzymes and juices are released into the duodenum. But it also has an endocrine function. It has a hormone function. So there are these little pockets of cells called the islets of Langerhans, or pancreatic islets. And inside each of these, you will see some alpha cells and some beta cells. The beta cells produce the insulin. The beta cells produce the insulin, and the alpha cells produce the glucagon. And so these two hormones then are released from these little islets into the bloodstream, and then they go and act on either the liver or the body cells. So here's the big picture of how these two hormones act for homeostasis, all right? So let's say that we have an increase. Let's say we have an increase. I'm going to write purple. Let's say we have an increase in our blood glucose. So what that does is that is going to stimulate the beta cells of the pancreas to release insulin. Insulin is going to flood into our bloodstream, and it is going to tell our body cells to absorb glucose. It is also going to act on the liver, and it's going to say, hey, we have plenty of blood glucose, so go ahead and take up some glucose and store it as glycogen. And so the result of that is that the blood glucose level falls. Notice that the reaction is opposite. The reaction is opposite to the stimulus. So this is a negative feedback loop. Now, let's take a look at what happens when, I'm I'm going to write in pink. So let's say what happens when blood glucose levels rise. So what happens when blood glucose levels start to rise is that we are going to, I'm so sorry. So then they would rise again. I'm sorry, we're starting on this side. Sorry, right here. So the stimulus is decreased blood glucose levels. So the decrease in blood glucose levels then is going to act on the pancreas, and this time it's going to be the alpha cells in the pancreas that are going to release glucagon. Glucagon is the other hormone, and that is going to stimulate maybe the liver, majority of the liver, to say, we need some more glucose. Hurry up and release some. So it's going to take glycogen, and glycogen, remember, is the starch made up of glucose subunits, and it's going to break that down, and glucose is going to be released into the blood, and so the reaction then is blood glucose levels rise. And so I have the opposite reaction here. My stimulus was low blood glucose, and my response is high blood glucose, and so this is another example of a negative feedback. But you can see these two hormones work antagonistically to keep the blood glucose level in homeostasis. So what actually happens in the cell itself is a signal transduction pathway. So remember, glucose itself is too big to just diffuse into the cell. So here's the inside of the cell right here. And so insulin is going to act as a ligand, and it is going to bond with an insulin receptor when it is stimulated, when the blood glucose level is high. And what happens then is that sends off a signal transduction pathway in the cell, a signal transduction pathway in the cell. And what happens is that turns on the glucose transporter in the cell membrane. And so glucose starts to come in from the blood. And so what happens is a couple of different things can happen. First of all, this glucose could be actually burned to produce some pyruvate, and we're going to get some ATP, that's cellular respiration. Or some of the glucose could be stored temporarily as glycogen. Or some of that glucose could be actually stored more long-term in fatty acids. So hopefully that's been helpful, and that's the story of how insulin and glucagon work to keep blood glucose levels in homeostasis.